This is the only vegetable that fights back before you even cook it. You grab a knife, make the first slice, and within seconds, your eyes burn while tears stream down your face. This kitchen disaster happens to professional chefs and home cooks alike. This reaction is no accident. It is a sophisticated chemical weapon deployed by a plant that really does not want to be eaten. The biology behind your tears is surprisingly complex, involving unstable gases, specialized enzymes, and a defense system developed over millions of years. Slicing into an onion ruptures thousands of microscopic cells rather than just cutting a vegetable. Inside these cells, the onion keeps two chemical components strictly separated: an enzyme called alliinase and a family of amino acid sulfoxides. Once the cell walls break, these ingredients mix for the first time. The alliinase enzyme attacks the sulfoxides and converts them into unstable sulfenic acids. A second enzyme, known as lacrimatory factor synthase, then seizes these acids and rearranges them into a volatile gas called syn-propane-thiol-S oxide. This gas rises from the cutting board and drifts into your face. When it hits the moisture in your eyes, it reacts with the water to create a mild form of sulfuric acid. Your brain detects the acid burn and signals your tear ducts to flush the irritant away. If you are enjoying this look at the hidden chemistry of everyday life, hit subscribe and the notification bell, since we break down questions like this every single week. We can now examine why onions evolved this way. Nature rarely wastes energy on useless features, and the onion's tear gas is no exception. This chemical assault is a deliberate evolutionary defense mechanism designed to repel predators. Since onions grow underground as bulbs, they are stationary targets for hungry voles, insects, and other ground-dwelling pests. The moment a predator bites into the bulb, the chemical trap springs and delivers a painful sting to the attacker's mouth and eyes. It acts as a botanical warning shot that tells predators to stay away. Garlic is a close relative, but lacks the specific lacrimatory factor synthase enzyme. Crushing garlic produces a strong smell, but does not make you weep. The onion stands alone in the garden as a chemical warfare expert that prioritizes its survival over your dinner plans. You can disable this chemical weapon if you understand the physics behind it. The most effective method is temperature control. Placing the onion in the refrigerator for 30 minutes before cutting lowers its temperature, which slows down the reaction rate of the enzymes and reduces the gas volatility. Another verified technique involves your choice of tools. A dull knife crushes cells and smashes them open to release large amounts of enzymes. A razor-sharp knife slices cleanly through the tissue to damage fewer cells and release less gas. Ventilation also helps significantly. Setting up a fan to blow the air across the cutting board pushes the gas away before it can reach your eyes. Some people suggest cutting underwater, but that can make the onion slippery and dangerous. The safest results come from using the fridge and a sharp blade. For every scientific solution, there are a dozen kitchen myths that fail to work. Lighting a candle near the cutting board will not burn off the gas fast enough to save you. Holding a spoon in your mouth or chewing gum offers no protection for your corneas. The only physical barrier that works perfectly is a pair of airtight goggles. Science has gone even further with sunions, a crossbred variety developed by plant breeders that naturally contains less of the lacrimatory enzyme. Regular onions get more pungent in storage, but these become sweeter and milder over time. We have effectively used selective breeding to disarm the vegetable and create a version that retains the flavor without the chemical weaponry. Finding yourself weeping over a cutting board reveals a feat of evolutionary biology. That humble vegetable is deploying a complex defense system that kept its ancestors alive for millions of years. We may have found ways to outsmart it with refrigeration and sharp steel, but the onion demands respect. If you enjoyed this exploration of kitchen chemistry, verify your subscription is active so you do not miss our next explanation. Thanks for watching, and I will see you in the next video.